the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcomes.
Hello, this is Roy Simpson, professor of mathematics at Casitas River College in Sacramento, California. And in this lecture, I'm going to go ahead and take a few moments to talk about finding the domain and range from graphs. So here we go. All right, as you can see from this example, that this is part of a series of examples on functions and kind of a review of functions. In this specific example, we are going to go ahead and work with the graph of an unstated function. So we don't have an equation here, but what we're going to do is go ahead and work with this anyway and just go ahead and state the domain and range of this function. Remember, domain is a set of all values, x values, that the function can have as an input, and the range is the set of all y values or outputs that the function can have. And with a graph like this, the domain is implicitly stated just by the graph itself. You could see that there are solid circles. I know it gets pixelated there, but there are solid dots there where the graph ends. If you are dealing with a graph that goes on forever, then it should be appropriately noted with a right or with arrow notation just like that. So what do you do when you're handed a graph and asked for the domain and range of that graph? That's pretty simple, actually. All you really need to do is take a look at the x-axis. Wherever there is a function value above or below that's shaded in, you'll shade that x-axis. So I'll just do this way. So you can see as I'm shading this x-axis, I'm shading it because above where I'm shading, the function exists. The function exists there, the function exists there. And I can continue shading all the way over to this point right here. And again, it's because the function exists above, and then over here I shaded because the function again exists below, all the way down to that point right there. And even at this edge here, the function exists because there's a y value associated with that x value for the function right there. If you look to the right, the same thing, right? You keep just shading wherever the function exists. If there was a hole in the function, you would skip over that point. And I'll give you an example of that in a moment. But that shading right there, at least for this given function, shows me the domain. Now, let's just pretend for a moment, just because I think this function is a little too easy, let's pretend for a moment that there was a hole in the graph right there. So there was a blank spot right there. Then how would you note that using the shading? And by the way, the shading is not an official way of doing this. It's not that this is acceptable for your math professor. It's just a way that you can kind of get the job done. So the way you would showcase this in shading is you get really close to the x value associated with that y value. You would skip past it and kind of continue on, and you would have a little hole in your x-axis right there as far as to signify the x values that you're plugging into your function, or that can be plugged into your function. And in that case right there, let's just pretend that that value was x equals 1.2. It looks like a 1.2 to me because these hash marks are every one, so I'm okay with that being a 1.2. If that were the case, then I would say the domain of this function, domain, would be from -5, because you start intervals from the leftmost point, or the lowest value, and it would climb all the way up to that 1.2, but it wouldn't include that 1.2 because, again, that 1.2 does not lead to a y value. That's in this fictitious situation, but you get the point. It would include the -5 because that -5 does, as an x value, lead to a y value on that graph. And then you would skip over the value of 1.2 and you would glue to that interval, and that would be via a union, another interval starting on the other side of 1.2 and climbing all the way up to, let's see, this is 5 right there, that's 6, and that is 7. And then you just close off that interval. Now, to be very honest with you, that wasn't the actual graph we were given. So I'm going to erase that, but this was the special case that, well, what if you had a hole in the graph there? How would you treat that situation? But for now, I'm going to erase that. And I'm going to start right back over, just fresh from the beginning. And again, to signify the domain, I will pretend as though I'm at the x-axis, and I'll highlight the x-axis wherever there's a graph of our function above or below. And so everywhere I'm highlighting, the graph of our function exists above or below. And so that tells me my domain goes from -5 to 7 for this specific function. So I'll write that down over here, the domain of this function, which I don't know if they gave me a function name for this, so I'm just not going to state one, but the domain is -5, including -5, all the way up to 7, including 7, because they're all solid dots. Now let's focus on the range. And the range is done the same way, except for you deal with this using the y values. So I will go ahead and shade the y-axis. And in this case, I'll use a different color here. And I will highlight, I'll just pretend as though you're standing at that y-axis. If you look left or right, if there's a function value, if your graph exists to the left or to the right, then you will shade. And so I can continue shading down all the way down to, let me zoom in here actually. That value looks like, it's a terrible graph, so it looks like it goes down to -8. I will not shade anything below -8 because if I try to, and you look to the left or right of that new shaded area, you will see that I do not have any graph over here or over there, so there's no point in me shading that part of the y-axis. And this shading technique really is very nice because then you get to actually see the range of your function graphically. It goes from again, you go from lowest value to highest value. So it goes from a y value of -8 all the way up to a y value of +7, as grainy as that may be. And so I'll go ahead and write that down. The range goes from -8 to +7 inclusive. I'm including those endpoints because you can see that solid red dot there, and you can see the solid red dot down there. Now, these graphs can be very complex. You can get very, very interesting graphs. This happens to be the only example I have here, but let's just, for a moment, pretend it looks slightly different. Notice that I've changed this graph significantly. I've actually erased part of it. Not so technically, I just used a white pen to do it. But now we can really have a good conversation about domain and range of a given graph like this. So again, I'm going to go ahead and start highlighting on the x-axis where I see part of the graph, maybe above and below. And actually, I'm going to make this a little more interesting. Something here just kind of caught my eye, and I would love to make this slightly more interesting. So I'm going to put a little dot right there. All right. So let's see, I'm going to start highlighting the x-axis here wherever I see the function above or below. So I see the function above or below throughout this region right here, all the way up to, but not including 0. So I'll have to kind of note that in a little bit. I also have to skip over a whole chunk of area here. If you get into this area right here, you'll see above and below, there's no graph. So obviously I don't have a function there, so I cannot have any shading. But all of a sudden at x = 1, you do see a single little dot down below. So I'm going to try to, I know that looks like a wide shaded area. It's just because my highlighter is kind of thick there. So that dot is, that shading there is supposed to be somewhat thin, but oh well. And then I continue forward. I have to skip through a region here, and I will go ahead and highlight all the way down to maybe around there, and all the way over to this point right here. I went a little too far there, but that's okay. And so when you talk about the domain, you can see we'll start at a -5, including -5. for the x values of the domain, and it'll climb all the way up to x equals 0, but not including x equals 0. So let me go ahead and write that down. The domain here will start at -5, including -5, and climb up to 0, but not including 0, because our function doesn't actually exist at x equals 0. There's an open hole at x equals 0, comma, y equals -1. And then I get to skip over a whole empty area. And remember what I said previously, skipping over just means you're unioning or gluing on another interval, or in this case, another point in space. And we notice that at x equals 1, the lonely little number 1, the function exists just briefly below. And the way you would note that using interval notation, well, you can't really in an interval notation, but you can using roster notation. So the set of a single element is denoted using braces like that. So a little brace around the number 1 just means I only have the number 1 there. And then I skip over the next group of numbers until I get to roughly what looks to be about, let's say 1.5. Let's just say it picks up at 1.5. But again, there's a little hole in the graph there. So we're going to union onto this and pick up at 1.5, but not include 1.5 because, well, you can't. There's a little hole in the graph there. And that is an interval that will continue on to x equals 7. So I'll clean up this. I dislike that handwriting there, so I'm going to actually put the 5 there, all the way up to 7. And we get to include 7 because the function exists at 7 below. That's the domain. Now, let's take a look at the range. So I'll erase the domain here. And now we're back to talk about the range. The range, I'll just go ahead and use that same yellow highlighter. If I had it on a highlighter, there we go. You can see it climbs all the way up to 7. And when you fall, it falls all the way down. And you may think that you can't include that point, but you can include y equals -2 because the function actually does exist at y equals -2. It happens to exist way over there. So I'll include that point, and it gets all the way down to here, including -2. Then it skips over a whole area right here. This region right in here is going to skip over because there's no function to the left or the right there. But then all of a sudden, just for a brief moment, at y equals -3, the function does exist. And as I mentioned before, my yellow highlighter doesn't really work. It doesn't do such a small dot there, but at least I got a little yellow dot there. And then we continue forward, right? And actually I want the black pen. And where do we pick back up? It looks about -5, so I'm going to go ahead and say we pick back up at -5, not including -5, and go all the way down to -8. So noting that in interval notation, again, interval notation goes from the lowest value to the highest value. So we'll start at the lowest y value, which is a -8. So the range here, if I said domain a moment ago, I meant range. The range starts including -8 and climbs up to, what is that, a -5 maybe, but not including -5. It skips over a region and picks back up at -3 right there. So again, if it's a single point in space, roster notation. Then it skips over another region and starts back up at 2. You get to include, or sorry, -2. You get to include -2. And it'll climb all the way up to 7, and you get to include 7 as well. So -2 to 7. -2 to +7, and you get to include that. So there's a couple examples in a row of how to find the domain and range from a given graph of a function. I hope that helps you out.
It's the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcomes obstacles getting in our way. Cause affects more than we can sometimes see. Things for what they are and work together until you feel at peace. Just listen close. Don't talk too much that isn't kosher. You may really hurt inside. It doesn't justify you to speak too loud and cry. just cheat.